You'll learn about SDN, Software Defined Networking. Before I explain what SDN is, we need to review the planes on our routers and switches. That's the data, control, and management planes. The data plane, which can also be known as the forwarding plane, that's where traffic is forwarded through the device. So if, for example, you're sitting in the office and you open up a web page out on the internet, and that traffic, the packets are going through the router, then those packets are passing through the data plane. So any normal production traffic, which the router is forwarding through its interfaces, that is going through the data plane. The next plane that we've got is the control plane. The control plane makes decisions about how to forward traffic. Control plane packets such as routing protocol updates at layer 3 or spanning tree updates at layer 2 are destined to or locally originated on the device itself. So if, for example, we've got a couple of routers, R1 and R2, and they're sharing OSPF updates with each other, well, when R1 advertises a route to R2, that packet originates on R1 and then it's destined to R2. So unlike the packets in the data plane, which are passing through the router, packets in the control plane originate from and terminate on the routers or the switches. Finally, we have got the management plane. The device is configured and monitored in the management plane. For example, if you're connecting to the router or switch to manage it through Telnet or SSH, you're working in the management plane. You could also be managing it via a GUI using HTTPS or via SNMP or an API, Application Programming Interface. Okay, so those are our three planes. Network infrastructure devices, your routers and switches, are responsible for their own individual control and data planes in a traditional environment. So all the packets that are passing through a router or a switch, it's a router or switch that is responsible for forwarding them in the data plane. And also, again, using OSPF as the example in the control plane, each individual router is responsible for updating its own routing table, which is how it makes those forwarding decisions. With software-defined networking, it breaks with the traditional model. So with SDN, it decouples the data and control planes. Rather than having both the data and control planes running individually, one at a time on each of our network devices, with SDN, the control plane is moved off to a centralized SDN controller. So the network infrastructure devices are still responsible for forwarding traffic, so they're still controlling their own data plane, but the control plane intelligence moves to a centralized SDN controller. Rules for packet handling are sent to the network infrastructure devices from the controller. And the network infrastructure devices query the controller for guidance as needed, and they provide it with information about traffic that they are handling. We can run SDN either as a pure SDN or as a hybrid SDN. With a pure SDN, the control plane runs purely on the SDN controller, and the data plane runs purely on the network devices. With a hybrid SDN, the majority of the control plane intelligence is again provided by the SDN controller, but the network devices retain some control plane intelligence as well as the data plane operations. And most implementations, including used by Cisco, use a hybrid SDN because it can be more efficient and higher performance that way. Okay, so let's look at the SDN architecture. The information on this slide, you definitely want to know for the CCNA exam. So with the architecture, everything is from the point of view of the SDN controller. So we'll start there. That is at the control layer. We've got our SDN controller, which provides the network services. Then it's going to be managing our network devices, our routers, our switches, etc. They are living in the infrastructure layer, which in the hierarchy is going to be below the control layer with the SDN. And because everything in the architecture is from the point of view of the SDN controller and the network devices are below it in the hierarchy, then we're going to be using southbound APIs from the controller to control the network devices. The APIs could be using OpenFlow, which was one of the earlier SDN protocols. It's open source. Other ways that the SDN controller can control the devices is via SNMP, a REST API, netconf, RESTconf, or SSH. It just depends on the particular implementation which will be used. Often controllers can use different protocols, and they will use whichever one is supported by the particular device that they are managing. Okay, we also have the application layer. That's where we have our SDN business applications. And because this is above the controller in the hierarchy, from the controller's point of view, it's going to be communicating with that with northbound APIs. Northbound APIs are typically going to be using REST. Okay, so let's have a look at this actually in action so you can visualize it. So I'll go back to my AWS example again. So if in Amazon Web Services, I'm going to be provisioning a virtual machine there. At this point, I've already configured all my settings. I'm just on the review page now. And you can see here that in this web-based front end, I've configured my network settings that I want on my virtual machine here. So I've specified the network, the subnet, if I want it to have a public IP address. I've also specified my firewall rules here as well. So this is the front end that the user is going to be interacting with me when I'm provisioning my virtual machine. And from here, we need to get the server configured. So I need to have the operating system installed. Also, I need to have all my network infrastructure devices. So I've configured all my settings in here. Looking at our hierarchical model, this is at the application layer. So this is my front end SDN business application. I fill in the information there, and then when I click the button to actually provision the virtual machine, the northbound APIs using REST are going to communicate with the SDN controller, and then it's the SDN controller which is actually going to push the configuration to my network devices below there. Because that's how it's typically going to work. You're going to have a front end that the user or the administrator is going to be interacting with. That's at the application layer. It uses a REST API to communicate with the controller, and then the controller will use its southbound APIs to actually push the config to the devices. Okay, finally, let's look at what SDN controllers are available from Cisco. First up, we've got the APIC, which stands for Application Policy Infrastructure Controller. And the APIC is the main component of Cisco ACI, which stands for Application-Centric Infrastructure. The APIC is designed to manage data center environments with Nexus switches. So when you're in an IT environment, typically it's your data center that is going to have your higher end devices in there. That's where all your services are located. So you want to have high performance there. And because of this, the data center is often the first place that new technologies are going to be implemented in. And that was the case with Cisco SDN. So if you had a Cisco-based data center, you were using Nexus switches there, you were able, or you still are able, to control that with SDN using the Cisco APIC. After the APIC was released, that's been available for several years. The next one that was available was the APIC EM. The APIC EM stands for Application Policy Infrastructure Controller Enterprise Module. So where the APIC is designed for use in data center environments and it controls Nexus switches, the APIC EM is designed to manage enterprise environments. That's your campus, your branch, and the WAN. Now, the APIC EM has actually been upgraded recently to the DNA Center. So DNA Center, it's got most of the same features and functions that the APIC EM had. The APIC EM has not gone end of life yet as I am recording this. It will do sometime though, because DNA Center is really the new version of APIC EM. The APIC used in data center environments is not covered in the CCNA exam, but DNA Center for your enterprise environments is. So in the next lecture, we'll be looking in more detail at DNA.